Hey everyone, today we'll be going over LeetCode problem 1436, Destination City. In this problem, we're given an array called paths, and this is a two-dimensional array, where each one-dimensional array it contains is a path, which is basically an edge, with a source, which is city A, and a destination, which is city B. So each of these paths represents a city that we are traveling from and going to. Now what we want to do is return the destination city, which is the city without any outgoing paths to another city. And we're guaranteed that we have only one singular destination city in each case. We have here an example below which I have rewritten so we can see it better. And we are told that we have three edges in this case. One going from B to C, one going from D to B, and the third going from C to A. In each case, the first letter is the source and the second is the destination. So we know that we have an edge going from city B to city C. So we know that we are going from city B, and this is going to have an edge which will lead to city C. We then have another edge which goes from city D to city B. So we can add an edge prior to this B, and we know that this comes from a D, meaning that we are going first from city D, then to city B. And finally, we have an edge which goes from city C to city A. So we know we need to add another edge going from city C and ending at city A. After having gone through this array, we see that all city D, city B, and city C have an outgoing edge, so they are not the final destination. While city A has no outgoing edge, it only has an incoming edge from C, and therefore it is the final destination, so we would return A in this case. Now, because we were given edges, we would think that this is a graph problem, but actually this is a problem which can be simply solved using a hashSet. So I will be showing you an algorithm which has both linear space and time complexity. What we are going to do is simply iterate through this paths array twice. The first time we are iterating through the array, we're going to go through each and every source in the paths array. Every time we encounter a source, for example, first B, we know that this cannot be the answer because it is a source, and so because it has an outgoing edge. So we're going to go and add it to our hashSet, which will contain all of these sources, or all of the letters, which will not be our answer. So we go through the B, and we know that it is a source, so we will add it to our hashSet. We know that this cannot be our answer. Next, we have our D. Now we know once again this is a source, so it has an outgoing edge, so we're going to go and add it to our hashSet. Finally, we have this C. Once again, this has an outgoing edge because it is a source, so we will add it to our hashSet. During the second iteration instead, what we're going to do is go over all of the destinations. And when we encounter a destination, which is not in our hashSet, we know that that will be our answer, because it is only a destination and never a source, meaning that it only has an incoming edge, but not an outgoing edge, just like this A. So first we encounter the C, but we go and check in our hashSet and we see that we have a C here. So this is not our answer. We then have a B as a destination. Once again, the B is in our hashSet, so we know that this is not the answer either. Finally, we have the A. Now we go and check in our hashSet and we see that there is no A in our hashSet, meaning that A does not have an outgoing edge and is never a source. It is only a destination. Therefore, we know that A is the answer and we can return it as our output. So this is our algorithm. We see that we simply go through the paths array, we iterate through it twice, once to store all the sources in our hashSet, and once to go and find the destination, which is not a source, which is not in our hashSet. Because we iterate through it twice, it is a linear time complexity algorithm, and because we use a hashSet, it is also a linear space complexity algorithm. So we said we're going to start off by creating our set, our hashSet, which will store all of the sources, which cannot be our answer. Afterwards, what we want to do is make our first iteration through the paths array. Now for each path, I'm going to destructure it in a source and destination, because we know that each path in our two-dimensional paths array is a one-dimensional array containing two elements, the source and the destination. Now what we will do during this first iteration is basically just add to our hash set each source. Then we're going to iterate through the paths array again the second time. And what we want to do is check to see which destination is not in our source set. Whichever is not in our hash set is our destination, our final destination, and so we can return it. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please subscribe to my channel. I'll see you on the next one.